Now we're going to look at functions in the form of f of x equals x minus h, that whole quantity squared. Now what the h value does of a parabolic function is it shifts the graph left or right, so it moves it along the x-axis. So I remember this because it's in with the x value. So the x that's being squared, whatever's inside the parentheses with it, that's what's shifting it left and right on the x-axis. Okay? And it's actually going to go the opposite way of whatever that sign is. And the way I remember that is I just think about what would make this parenthesis 0, just like finding our zeros, and it's always the opposite sign of what's in there. Okay? For example, I have this graph, g of x equals x minus 4, all that squared. So the vertex of our graph is now going to be shifted to the right 4 units. All right, so this was a negative 4, and what would make this parenthesis 0, or what would our 0 be, or our roots of this function? It's what would I have to add to negative 4 to make that 0, and that's positive 4. So I'm going to go over 1, 2, 3, 4 units to the right, and then I can graph my function. So if you wanted to try that 1, 3, 5 method as your shortcut, remember our a value is positive, so this is going to be going upwards, and it's 1, so I can use that 1, 3, 5 directly. I would move from the vertex, right 1, up 1. So that's the first. And same thing, left 1, up 1. Then from this point, I would still move over 1 unit to the right, and then up 1, 2, 3. Same thing, back 1, up 1, 2, 3. Again, when in doubt, you can always use your XY chart to find more points. So we already have the value 4, 0. From there, I would pick values on either side of that vertex. So on the other side would be 5. If you plugged in 5 for x, 5 minus 4 is 1, and 1 squared is still 1. So that gives us the value 5, 1. We know it's going to be symmetrical, so I know if this went over 1, up 1, this is also going to go back 1, up 1. So I'm going to have the value 3, 1. If we plugged in 6, 6 minus 4 is 2, and 2 squared is 4. So that gave us the value from here, 5, 6, up 1, 2, 3, 4. Again, it's going to be symmetrical, so we can find this value on the other side, and then we graph it. Now the axis of symmetry on this one is not x equals 0. What do you think it is? What is this line here? Right, because that's the line that makes it symmetrical. It's a mirror image over that line. It's a vertical line, so it needs to be x equals a number. And in this case, 1, 2, 3, 4. So x equals 4 is the axis of symmetry. Why don't you try this example on the right, and also try to find the axis of symmetry. Alright, now we're looking at f of x equals x plus 2 squared. So the vertex of this graph will be at negative 2, 0, right? It's the opposite sign. This was a positive 2. My vertex is going to be at negative 2 because the root of this function would be negative 2 plus 2 would give me 0, right? So I go and plot the vertex at negative 2, 0. Then I can either use that 1, 3, 5 method, or I can make an XY chart. So either points on either side of this, the vertex would be -1. If I plugged in -1 plus 2 would be +1. +1 squared is 1. And so again, you see that over 1, up 1 happening. It's going to be symmetrical, so I know this value at -3, 1 will also be there. I can go to plug in 0 for x. 0 plus 2 is 2. 2 squared is 4. So 0, 1, 2, 3, 4. I know it's going to be symmetrical, so there's going to be another value here. And again, you could see that 1 through 5 works. Right 1, up 1. Right 1, up 1, 2, 3. You could also go right 1 and up 5, but we're off the graph. This is a U shape. And it's going to continue on forever. Now, the axis of symmetry. Symmetrical right across the vertex. And that's going to be at the equation, or the line. The equation of that line is x equals -2. And there you go. There's our graph. In the next equation, or the next video, we're going to put all of that information together with the a, h, and k, and graph equations in that form.